This is the table layout and power scales, patterns and successive differences. I would have the students lay out our multiplication table or the decanomial and invite them to come to the rug for this presentation. I would start with the students reminding them that we have already looked at the commutative property, but there is another way that we can look at the relationship of this table. If I point to the 10 bar and the 1 square and ask the students how I could also look at the 10 bar, 1 square plus what would equal the 10 bar? The students could show me that 1 square plus 9 would equal 10. If we go down to the 2 10 bars equaling 20, and I move to the 2 square, which is 4, how could we take 2 square? What would we add to equal 20? The students could work with the different beads and come up with the answer of 2 8 bars equaling 16. So we would have 2 square plus 16 equals 20. If we move down to the 3 10 bars equaling 30 and to the 3 square, which equals 9, the students could tell me that 9 plus 21, the 3 7 bars, would equal 30. We would continue to move down to 4 10 bars equaling 40. Look at the 4 square. I would ask them, what does 4 square equal? How many beads are in a 4 square? 16. What would they need to equal 40? This would be 4 6 bars equaling 24. So we would have our 4 square, 16 plus 24 would equal 40. At this point, I would ask the students if they're recognizing any pattern, any relationship. And I would have them work the 5 square plus what would equal 50. At this point, I'm hoping that they would see that the 1 square plus the 9 equals our 10 bar. If we move in 1 from the left, in 1 from the right, that would equal our 20. After this material layout, I would come down and I would have graph paper so that we could work on the paperwork of showing the power scales. The first step that I would have the student take is to write our squares across the top of the page, starting with 1 square, skipping one of the graph squares, 2 square, again skipping a square. We have 3 square, all the way across to 10 square. The next step for the student would be to have them write how many beads would be in each square directly underneath where they have written their square numbers. 1 square is 1, 2 square is 4, and I would have them continue this again all the way across. From here, I would ask the student if they see a relationship between our total number going from each answer. So the difference between 1 square and 2 square would be 4 subtracted by 1. We would write 3 in the center square. The difference between 3 square and 2 square, or 9 subtracted by 4, is 5. The difference between 4 square and 3 square, or 16 minus 9, is 7. I would do this all the way across again. At this point, some of the students may have noticed that we also have a pattern in the last line that we did. And if we look at the difference between those numbers, 5 minus 3, the difference is 2. If I write a 2 on the next line in between, and then go to the next ones, I have 7 and 5. The students would tell me the difference again is 2. 9 minus 7, 2 is our difference. 11 minus 9, 2. And the students could continue. 13 minus 11, 15 minus 13, all the way across. And we've found that we have a constant pattern through the scale. This next presentation, I would invite the students back to the workspace. We're going to be looking at our cubes to see if we can find a similar relationship as we did with our squares. The first step, I would have the students, again, write their cube numbers across the top of the graph paper. 1 cubed, all the way across to 10 cubed. And then I would invite the students to use the materials if needed, but to tell me what each cube would equal in the number of beads. They could use the materials if needed. 1 cube would equal 1. 2 cubed would equal 8. 3 cubed, or 3 times 3 times 3, would equal 27. 4 cubed would be 64. 5 cubed would equal 125. And I would have the students complete this all the way across. When they've completed that step, I would ask them if they remembered when we did our power scale of squares, how they found our next row of numbers. We found the difference between squares. In this case, we're finding the difference between our cubes. 8 minus 1, 7. 27 minus 8, 19. 64 minus 27 is 37. 125 minus 64 is 61. We would go all the way across. 216 minus 125, 91. After they've completed that step, at this time, the students probably will tell me that again, we're going to be looking for our differences to find the relationship. We would look and find the difference between 19 and 7. We have 12. 37 minus 19 is 18. 61 minus 37 is 24. 91 minus 61 is 30. 127 minus 91 is 36. The students might begin to see the pattern of what's coming next, and they can complete this step quickly, and then tell me that the difference between that row is 6. 18 minus 12 is 6. 24 minus 18, again, is 6, all the way across. At this time, the students and I can come up with the rule that the scales demonstrate to us that the growth is constant at different rates between both squares and cubes.